Given that x plus iy squared equals to 12i minus 5, where x and y are real numbers, we want to find the set of possible values of x plus iy. Okay, so this is a very standard question. We need to compare. What we're going to do is we realize that x and y are real, right? So what we'll do is we want to this is a question where we want to compare the real and imaginary parts of the equation. After that we equate the real and imaginary parts, right? So first what we do, you see that x and iy, we want to solve for them, but they're stuck inside a bracket, so we can expand. So first up, if we were to expand, right, we will have x, this just give us x squared plus 2ixy plus iy squared, which is minus y squared, right? So it's minus y squared to be equals to 12i minus 5, right? If we were to split the real and imaginary part, this will be the real part, and the imaginary part will be I of 2xy equals to 12i minus 5. Okay, and then over here, if I compare, this will be the imaginary part. Can you see? And if I use the green arrow, you can see that this will be the real part. Okay, this can only be done if the coefficients are real, right? The real part is real, x and y are real, imaginary part are also real, right? So just like in tutorial I showed before, if I will do something like this, for example, I 2w plus 3z plus 3w minus 2z equals to 4 plus 5i. Okay, but if w and z, they are a complex number, can I say this is equals to this? No, right? Because the real and imaginary part here is not, they are not clear, right? So we can only do this, we can only do if only this part are real. We can only compare only if the parts are real. Alright? So remember this, we've seen this before in our lecture question, right? So here, x squared minus y squared equals to 5. So equating the comparing the real and imaginary parts, right? X squared minus y squared will be equals to negative 5. 2xy will be equals to 12. Okay, on top of that, from 2, so very quickly, we can just create a substitute from equation 2. Alright, we let x to be equals to 12 divided by 2y, which will just become 6 over y. Alright, we can use it as a substitute. Okay, we will get sum into 1. Okay, so what follows are just very mandatory substitution, right? So just sub, so you have 36 y squared, because this is x squared, okay, minus y squared equals to negative 5. 36 minus y power 4 equals to negative y squared. Okay, and eventually you are solving y power 4 minus 5y squared minus 36 equals to 0. You have y squared minus 9, y squared plus 4 equals to 0. Okay, and follows that your y equals to 3 or negative 3. It cannot be y squared plus 4 is no solution, right? Y squared, because remember y is real, so there is no solution, right? So y squared equals to 9 equals y equals to 3 or negative 3, and substituting back into your equation, you have x equals to 2 for y equals to 3, x equals to negative 2 for y equals to 3. Alright, and with that, x plus iy equals to 2 plus 3i or negative 2 minus 3i. Alright, okay, let's look at the next part. Hence, solve the equation z squared plus 4z equals to 12i minus 9. Okay, so you can see that there's a hence part. It means we need to think about comparing to what we have found earlier. So looking at the earlier portion, let me just write this out. This is 12i minus 5, right? And looking at this question now, this is 12i minus 9. So we think, they kind of look similar, right? What can I do? So I look at this, minus 5, minus 9. How about I bring, maybe I can add 4 to both sides. So if I add 4 to both sides, you see what do I have? I get with z squared plus 4z plus 4 On the right hand side, I have 12i minus 5. And I look at my left hand side. Oh, now the right hand side looks similar now. What about the left hand side? Can I do something to make it look like a power of 2? I can factorize this. You see, you have z plus 2 square. Alright, and then compare. These and these are the same, correct? So you can just say that, now you can compare. X plus iy is the same. Can you see, if you compare x plus iy, it's just equals to z plus 2. Right, they have the same. This is just a replacement of variable. You're just doing a replacement of variable. So x plus iy can be replaced with z plus 2. And x plus iy, as we have found earlier, x plus iy is equals to 2 plus 3i, or equals to negative 2 minus 3i. Alright, and this is equals to z plus 2. So bring over 2 to the other side, z is just equals to 3i, or minus 2 to minus 4 minus 3i. Okay, with that you find z. So basically what we do is, you can see that starting off they are not the same, but I can add a 4 to both sides. My right hand side becomes the same. My left hand side is this. I factorize it. I compare. X plus iy is z plus 2. Okay, and we are done.